So yeah, before I start going into my slides, I just want you to imagine this scenario. If you are a developer and you are working under a very tight deadline, and you have your reliable AI coding assistant by your side, maybe auto-completing some functions, generating some code, suggesting dependencies. We call it, have you ever heard about this term vibe coding? So this is where the ideas, it turns into the code basically instantly and effortlessly with the help of AI. So this is all sounds like magic. But if we have a piece of code in the dependency that just gonna affect the entire application, this could turn into a nightmare. So this is what I'm going to talk about. It goes back to the topic of software supply chain. If you know about software supply chain in the past, but you probably wouldn't realize that over the time, it actually evolved into something that's pretty new. For example, AI, the usage of AI that could lead to that landscape. So hi, I haven't introduced myself. My name is Emma. I'm a security architect at EPAM. I'm also leading a team at EPAM for the UK and Ireland. So I'm leading a group of security architects and engineers. I have 12 years in AppSec, cloud security, mainly in Azure. And I'm a passionate mentor. I also speak at international conferences. I just came back from Las Vegas. So I spoke at DEF CON. I delivered 2 talks at DEF CON, one of which is about cloud security. So that's me, and I love travel, love hiking, cooking, everything, that's quite normal. So software supply chain is no longer simple. I would like to kind of introduce some of the recent attack. I just want to talk about the idea that it is complex at the moment, and global network of code contributors and open source projects and third-party vendors. So open source software makes up about 70 to 90% of all the modern code bases. We've seen all the kind of attacks. Sometimes the dependencies, attack on the dependencies could turn into an approach for attackers to deliver ransomwares. And now that is the current state. We all been using AI code, AI code assistance, and that's, why do I click on this? I just want, yeah, okay. So that's basically what I want to stand here and talk about. But let's go through some of the basic and the history of software supply chain. So we need to understand what are the threats of software supply chain and how they affect the system where they are vulnerable. Because almost every software nowadays contains a component of open source, libraries, and dependencies. And these dependencies and containers images, they are building block of any applications. And any vulnerability that deploy into an application that could spread the vulnerability, that could be spread throughout the CI/CD pipeline. So the XZ backdoor, you probably have heard about this, is a campaign that lasts 3 years before it's being discovered. So the malicious codes were planted in multiple versions of the open source project, where the attacker was able to maintain persistency of this attack without noticing. So this is an example of using the act of social engineering to maintain the trust within the open source project. And SolarWinds is a very famous one. I don't need to explain too much about it. Basically, it's exploit in the internal build system of the Orion platform. So there is malicious code injected into the software updates of the Orion platform, and this attack has impacted tens of thousands of downstream customers, which shows that even if you are trusting a third-party vendor, and which seems to be stable and trusted, but still something could lead to disaster. So dependency confusion attack is a type of attack that actually quite interesting because it builds the prioritization mechanism used by certain package. So when they have this condition of naming collisions between the private and public registries. So examples would be if your organization have a private package repo to store your internal packages, and if there is the same package that has the same name in the public repo, then that could create an opportunity for the malicious package to be injected into the public repo, and your internal repo will probably going to pull that repo off and install the malware. So that is one of the attack vectors. So this type of attack is called typo-squatting. So it's very clear from the name of typo-squatting is exploiting the typo, the spelling mistakes in the name of the packages or dependencies. So attacker could publish malicious package in the public registries, like container registries, or even dependencies registries like npm, and using the name that's slightly misspelled, and you don't even notice. And developers would just automatically, download that from the public repo. The last one I would like to explain is is actually something that could happen in the artifact. So when you package everything together, that turns into an artifact that could be a container image, something like that, that could be poisoned. So how this can be poisoned? It could be, this is an example, Code is a code testing application. So this example is exploiting, is the vulnerability has been exploited in a Docker image creation process. So the artifacts were affected, also affected a lot of downstream customers. Now come to the slope squatting. How many of you have heard about this term? Okay, cool. It's not new. So basically, this type of attack creates an opportunity for the attacker to publish a malicious package under the exact name. However, that package may be non-existent, may be malicious. So as the example or scenario that I described at the start, so when you are as a developer, you use the AI coding assistant like Copilot or GitHub or Copilot, whatever you use. I mean, there are plenty of tools out there in the market, and that causes this problem causes when the AI recommends the code with a non-existent or malicious, or use another word, hallucinated dependency. So attacker could register their dependency name with the malicious code on the same package that the AI is referencing. So as a result, developer could install that dependency or package, and this could lead to compromise. So what happens in the open source? If you're asking me, okay, so what then? If we have a malicious package in our system, what kind of consequences that it could cause? So most of the cases is that the attacker is able to open a command and control channel, which is also called backdoor, plant a backdoor, and remain access into your system. So that's probably the most dangerous things that you could experience in your system if that's the case. Sorry about this very overwhelming page, but but this page talks about the attack surface when it comes to CI/CD pipeline. So it's a wider attack surface. So if we only considering the dependencies, which is at the beginning of the CI/CD pipeline, getting into the code into your system, then there are plenty more happens downstream. So then you would know one of the vulnerability if it goes through the pipelines that could create a greater impact. So exploiting a CI/CD pipeline could be something like exploiting the CI runner, the CI server, the build server, something like that. So I'm not going to go through each one of them, but this is something that's really interesting, because if you imagine in your CI/CD pipeline, you have so many secrets going on. That could be maybe in one of the config file, because so in my project, I just want to be honest. In my project, it's a very common practice for us to for the developers to write test code with the implanted secrets and credentials. They like to do that because they want to automate everything, right, in testing. So this creates an opportunity if that piece of code is being obtained by an attacker, and if that credential is still valid. So that is that's very dangerous. So yeah, what is the impact? So the impact could be anything: data exfiltration, and there will be serious impact in the reputation of your company, loss of customer trust. I don't need to talk about that. You know, your business impact analysis will probably show everything about this. Now I would like to introduce Zero Trust. I don't need to introduce it because I know everybody is using Zero Trust principle at the moment. But you will probably never think about, okay, I need to use Zero Trust in the supply chain. So what is Zero Trust? There are three different principles that I summarize here: least privilege access, verify explicitly, and assume breach. So, sorry, what am I doing? Yeah, okay. Okay, so yeah, so when Zero Trust going into the, when Zero Trust applying into the supply chain, it turns out to be something about verification and how you verified your supply chain in terms of your CI/CD pipeline, how to verify every access to the CI/CD pipeline, and the artifact integrity. What's the time now? Okay. So yeah, what are the mitigations for this, for the scenario that I described earlier? So so these are the methodology for applying Zero Trust. I will explain all of them in a minute. So first of all, how to choose dependency and library safely. Sometimes you probably think about, okay, this is quite obvious that you need to go for the trustworthy dependencies and libraries, but the fact is a lot of developers just don't check about this. They're just gonna go with whatever libraries work for them and that they want to deploy them for efficiency. So you can look for the signs of legitimacy by verifying the publisher's badges, and you can verify the package sources, and always verify the existence and reputation of any package name suggested by the AI before installation. And community feedback can be a very good way to check whether that package that you are after is a valid one. So I'd like to talk about version pinning, because version pinning is something that's almost, mostly being forgotten when we are deploying a large project. So in the project, we have different version updates. So without pinning the versions, tools like the repository would pull the latest compatible versions. So if you imagine that you have multiple developers are contributing to the same repo, and one of them pulling one version of the dependency, another one's pulling another version, which is resulting in another dependency tree is being pulled, which means that there will be an inconsistency of that. So if you're using things like log files, I mean, in the case of the npm, if you're using log files, so even if the package have released the new versions, you will be able to ensure that the trusted version of the dependency which you have reviewed and tested will be downloaded instead of the one that is is the newest one. So newest one doesn't mean that is the best. You have to test and review everything, and verify everything. So that's the idea of the version pinning. So, oh, why do I always try? Okay. So another way to verify your package would be to, obviously, would be to use digital signatures and hashes. So how do you deploy this? How do you apply the digital signatures and hashes? So you need to verify your package before installation and before the deployment. And after you have downloaded that package and verify that is coming from the right resources with that digital signature. So, sorry. So how does it calculate? When you install a package, the repo will calculate a hash of the downloaded package, and it will compare with the integrity hash in, for example, in your log files, if you're using log files, like I said in the previous slides. So that's how you can verify the integrity of that file. Let's move on to the software composition analysis. So software composition analysis is also called dependency analysis. So listed here, I have a few tools that we have been using in the past. Most of them are open source, and you're welcome to use any non-open source vendor, commercial tools as well. But those ones are the ones that I would recommend if you're using the open source ones. So sometimes your package manager, like npm, could provide a better scanner if you are able to use them, because it will focus on the known vulnerabilities you need to consider for your dependencies. And so what is sandboxing? So sandboxing is something that is not just related to limiting the spread of your. It's not just relating to limiting the spread of your vulnerability, but also if you download your dependency into a sandbox, for example, like a disposable container or lightweight virtual machines, you can use that to test your dependencies before they deploy, or artifact, or like a container image, before they deploy into your downstream systems. Okay, SBON. I think probably all of us have heard about SBON before. So SBON is a complete inventory of all the software components, dependencies, and the metadata and relationship between different between the dependencies within this software project and artifact. So when you are using SBON, there are some red flags that you can check against. Some of the SBON are very good because they could flag up things like known malware, known vulnerability CVEs, and even typo squatting. They can compare the names between the valid names and the names that they could call up as a typo in that package. And sometimes it could reference to the license risk. So some of the best practices about SBON is to enforce it within the CI/CD pipeline. This is actually, in fact, in reality, is really hard to enforce because you don't want your builds to fail automatically at every pull request, whatever the gate that you are setting. However, my recommendation is, depending on your risk appetite, maybe to have a separate pipeline that you allows you to run the SBON at every pull request for your build. So in this way, it won't affect the main build, but at the same time, it could run the SBON and identify if there is any vulnerability in your code. So on my screen here, I have shared with you a example of an SBON that we have been using. So as you can see in the SBON at metadata, you will be able to see the version of that dependency, and the dependencies and the vulnerabilities that are listed associated with that dependencies. And this is another example of the SBON output. So as you can see that it shows the details of the vulnerabilities. And it could also provide the recommendation and suggested versions for upgrade. I think another interesting feature of SBON is that it could also show the relationship between the components, such as the parent-child relationship between the direct and transitive dependencies. That's really good too. Okay, this is interesting. So how can we train AI to handle everything safely? So we could try to lower the temperature or the randomness of the LLM, the large language models, during the code generation. That could reduce the likelihood of hallucination. And sometimes you could use, because the AI coding assistants may rely on the statistical patterns from their training data to predict the package names. Sometimes you can use a reason enhanced agent. So this could be something that could simulate the human-like reasoning and attempt to understand a broader context. For example, the version, the source of that dependency. So in this way, it could lower the chance of getting hallucinated dependencies. However, it doesn't eliminate them completely. So as I mentioned before, we can use a sandbox environment to deploy our code before it goes into the main code deployment. And you can also train AI agents. If you are using internal AI agents, then you can train them to interact with the trusted package registry in real time. So you will need a data scientist specialist in your house. Okay, I'm going to quickly go through this. So I've talked about dependency signing, but another very important thing in the CI/CD pipeline is the artifact signing. So basically, this means that you also need to sign your binary, containers, images, and other forms of package code. So this could be used to verify the code or binary integrity. And so if something in the artifact is altered, the signature would become invalid. So that is the idea. Again, you need to enforce that in the CI/CD pipeline. Okay, so in terms of protecting your CI/CD pipelines, that is the workflow. So workflow such as the branch, your workflow of your branch, like who is going to approve, who's going to do the code review, needs to be defined clearly for. It's really hot. Needs to be defined clearly for your company. So each company have your own branch policies. So and also audit and monitor your CI/CD runners to detect any anomalies, and maintain an audit log and monitor your pipeline. A bit of guidance around secret management. We all know that don't hard code your secrets. So you can use secret managers such as the AWS Secret Manager, KMS, Azure Key Vault. You can also use something like the GitHub CI secrets to manage your CI/CD secrets. Depending on what you use, you can use different kind of tools that are native to your platform. Yeah, okay. And the real-time observability is also something quite a standard for manage and protect your runtime environment. So in terms of cloud-native observability, you can use ePBF-based networking and security observability tools to detect some anomalies. So those are the examples of the tools. Yeah. So another thing that could be integrated into your supply chain assessment program is to adopt one of the framework. So there are two frameworks that are mainly used in most companies. One of them is the NIST Secure Software Development Framework, and another one is SASA. So so both of them, I mean, well, it's not mandatory to use them. However, using them could help you to compliance with regulatory requirements like DORA or Cyber Resilience Act. If you read about those documentations, it does require you to understand what is in your supply chain. So that is a screenshot of the supply chain levels where you can assess at different kind of levels for the SASA framework. Okay, so that is the final list that I would provide for my developers to check if they have achieved all of them. In the real life, it's hard to incorporate all of them in the processes, but we need to start somewhere. That's all. Thank you. Any questions?